Assalamu alaikum. This is MATLAB Lecture number 10, Simulink Part 2. We want to solve this set of differential equations using the Simulink. As before, we have to go to New. From the New, we have to go and select Simulink model. Surely we have to start from scratch. So as you see here, we have the area. We can design our Simulink. Now, as you see, the equations are x dot y dot equal 1, 0 plus. So it's better to write it in a form, and we have also the initial conditions. Let us write it in a form that u equal to x dot y dot equal to c. It is the 1, 0 constants, plus a, these are the factors, minus 5, minus 2, minus 5, 1, 0, multiplied by u, it's the xy. Say that we want to start by, again, we have this equation, u equals c plus au, plus a u dot, this one u dot, sorry guys, this one should be u dot. Anyway, or k or m, anything. Now we have equation, the right side will be equal to the left side. We will start by the right side. We have c. What is c here? C represent a constant vector 1, 0. So we have to go to library. From library, we have to bring, say that, the constant. You can take it from, say that, well-known or commonly used. Here we have a constant. This constant, the value of the constant, it is not 1, by the way. We can write a vector like this. It is 1, then semicolon. The second value will be 0 as a vector, column vector. Enter. Okay. If you want to name this constant, double click under this name and say write something here that this represent the c as example. This is the c. Okay, it's in red. There are a warning, unrecognized function or variable. Why? This is it should be 0 by mistake. It's good to learn from our mistake. Okay. Next, we need also here, we need the a constant. We can bring another constant and we can name it here as a. Double click. What's the value here? The value, it's a matrix. This matrix, it should be minus 2. So we have to write minus 2, comma, minus 5, semicolon to go to next line, then 1, comma, 0, close it. Like this. Apply. Cancel. So it is 2 by 2 matrix. The name is A, and this is C. Not the name, it's just a title or label. So we have here, as you see, we have the A, we have the C. We need the Y, the U itself. We need the U and U dot. So let me take constant and name it as a U. Okay. So this constant, say that this is U value. Okay. And Control C, Control V. Say that this is U dot. I know it's not a constant, but let me say that. I will change it later. Okay. So u dot, keep it away. U dot in our example here equals c. We need adder. Say that adding. So I will go to math operators. Where is the add? This is the add. How many components? We have to add 2 components. Double click, add plus plus. If there is one of them minus, you can change the signal to minus, but both of them positive. We need c plus. Here we have C. Where is C? This is the C. Connect. Click here and click here to connect. Okay, you can resize this add operator. Oh, I'm sorry, by mistake. Ctrl Z. Like this. Okay. And we need also here, we need to multiply A, as you see, A by U. So this is A and this is U. Say we can instead of saying A as a constant, we can go to gain directly. Both of them will work well, never mind. And the gain itself, we can define it as a vector. So I will copy this one, this gain matrix, copy. And no need for this one, delete it. And I will make the gain as a matrix. Okay. So it is U multiplied by this matrix. And this one should be added to the previous one. So let me make it like this, better. Okay, so this is C plus U u multiplied by a equal u dot. So the signal go out from here, it should be u dot. So we can say that this is u dot, because the equation, it is u dot equal. Now this u dot should be integrated. So let me go and take and bring from math or from continuous functions here, take the integrator, connect this one to here. That means this should be u dot. The result out from the integrator, it should be u. So this here, it will be u. It should be u like this. Now, where is the u here? This is the u. Delete it. It's not a constant. We know that. It should be taken from here. So I will connect this one to here as a u. It's like a for loop or while loop. The simulink will find the correct result. So this is a u come from here. You can double click here just to remind yourself, but u here also. Take it out like this. Okay. So u multiplied by a factor, which is a matrix A. Okay. Plus c, it will be u dot, integrate it. Okay, now the integration, as you see, x of 0 equal y of 0 equal 0, the initial conditions. So the initial condition here, it will be 0. Never mind. Now if I run the program, I will get the result of u. So let me take it to the scope. So let me go to the sync. From the sync, we can take the scope like this, connect the u, control again, control, click and connect. You can do like this. So guys, now we represent it, but I know there will be a mistake, because here we are applying a signal by matrix. We should take it element by element, but I didn't do that. So let me say that this is the second exercise. I will remove this one, no need for it. Run, I will get a mistake. See here, question mark here and here and here. That means there is something wrong. What is wrong, guys? Because the gain, it is a matrix, and the time, it is a vector. So we have to make it element by element. So I will go to the gain here, double click. See, it is element wise. Element wise. We have to take it as a matrix form. So matrix multiplication, keep it. K multiplied by u. K, it's the A matrix, and u, it's a signal. So it's K multiplied by u as a matrix. Apply. Okay. Now save and run again. Everything is okay. See, we don't have errors, and we have the output. See the output, it is the time, 56 double, and the simulation here, we have the data in a structure. We have model information, as you see, model name. We have many information as a structure. So the simulink solved the problem. How can I see the result? We can double click on the scope like this. See, why, the question is why we have two signals here. Why? Because if you remember u here, u dot, sorry, it represents x dot and y dot. So we have two equations with two unknowns, the x and y. So the first one x and second one is y. One of them x, one of them y. Again, you can add legend, you can do many things, you can resize, you can change the background, everything. We have many options here and here and here. So this is just a simple example to introduce you what is the simulink. Again, let me go back to library, show you different things. In this library, guys, we can say that this is output here. We can connect this is to output. If you have input also, we have something in the source. We have input here. Yes, this is input. We can say that this is input. This one should be input, and we have to define it. So input output could be used. Options also, guys, to output results. Let me go to sync. You can take this value as a vector or matrix to the workspace. So sim out, we can use sim out like this. As you see here, guys, we can see the solution as a structure, but I want the solution as a matrix, individual matrix. We can connect the u to the sim out. Now let me show you, run the program. What's wrong here? It should be individual matrix here. Let me go back to the simulink. let me go back to our simulink, see what sim out limit data point infinity one time series, save format, not time series, say that array, we can change it as array, apply, okay. Now save, you can rename it, not sim out, say that I want it as solution, not sim out. You can change the name, you can do what you want. Solution, save, run the program again. Sim out, it's yes, now it is a solution matrix in the sim out structure. See, this is the X and this is the Y, both solutions. Also, if we go to library again, also we have, let me show you continuous derivative integrator. By the way, we have another integrator, limited integrator. This integrator, it's open, without limits, from 0 to 1, from 0 to 10, integrate in general. But if you want to integrate, as example, from, we can replace this one, delete, and we can put this one here, okay? And we can connect this one to here. And we can connect this one to here. Okay, now in this integrator, we will integrate from, say that, from 0 to 10. In this case, I think no need for the initial condition because they will disappear. The constant will disappear, no need for initial conditions. They are there. So as you see, double click here, we have got the solution. PID controller. If you remember or if you know what's the PID controller, you can use it anytime, and you can put the proportional integral derivative coefficients or variables. Also here we have transfer function. We have many math. We have many tools. Dashboard. We can take the signal to custom gauge. We can use custom gauge as input. This one it's input, knob it's input, sorry, the gauge it is output. You can use it like this if you have certain values, okay. It will give you single value, not a matrix. We have many instrumentation here, which is new in this version. You can use them. Strings, you have functions. By the way, user-defined function. We can add a user-defined function like this one. Say a function like this. Okay, double click. See, this is mathematical function. You can write expression. Okay, this is a mathematical function. You can change. Sorry, again, you can change the function. Say that it is x to the power 2. It is x, the input signal x to the power 2. X to the power 2 plus 5 as example, and here write dot, apply, cancel. So the input is x, the output will be the result of the function. You can connect it to the design you want. If I want a MATLAB function, see this one, it is MATLAB function. MATLAB function, if you remember how we can define MATLAB function, we have inputs, we have outputs, and we have the block. Double click here, see, this is function, the return, it is y. Say that we need y and z as example, 2 outputs, and it accepts 2 inputs. Say that it is u and k, anyway. And we have here to define the value of y and the value of z also. So z equal 5 as example. Anyway, it depends on the function definition you have, and you can use it. So again, like this, connect this one as example. Let me bring a constant. Here, and Control C, Control V, another constant. Connect this one to here, connect this one to here, and it should give us two outputs. We can show them using the sync. We have here display to display a value. Connect this one. This is the first one. Control C, Control V. The second one. Display both of them. Now let me change this one to 5 and this constant to 10 as example, just to show you how we can use the function, the MATLAB function in our code. Run. We'll see the result here and here. Should not take this time because we just added this one function. Anyway, see the result here 5 and 5 because z here, see y equal y, u it's 5 and z equal, say that 5, it's okay. Or we can say that 5 multiplied by k, multiply by k, and save, and then close it, and then go back to the system, run again, and wait. It's 5 by 50. So this is how we can use this function. You can actually make it as a subsystem and put it here inside if there's a need. I think as introduction how to use the simulink, it's very clear and no need to go further. In next video we will solve the more exercises using the simulink. Thank you so much for watching this video. See you in next videos.